Hello guys, this is Prime Concept. In this video, I want to consider a very important concept, especially important to those that are carrying out experiments on convex lenses. Now, you are carrying out an experiment on a convex lens. You have your object and then you have your screen, which is where your image would be formed. And there is a minimum distance that you should keep your object and your screen so that you can capture an image on that screen. So if that minimum distance is not clear to you, you may put your screen at a certain position and expect to find an image there, which would not be possible. So in this video, we want to consider the minimum distance that should be between an object and its real image so that the image can be captured on a screen. So, and I'm going to call that distance D. So we want to find what the minimum value should be so that we don't go below that value. So follow me, do well to stick with me to the end of this till the end of the video, and the concept will be clear and you'll see how useful it actually is. Now, remember we're considering a convex lens like this. Now say this is our focal point F, then this F. We have our object O, we have our image I, such that the distance from our object to our lens center is U. The distance from our image to our lens center is V. So if I check for the distance between the object and its real image, I want to call it D, small letter D. So I'm going to call it D. That is the distance between object and image. Now you would notice there's a relationship between D, U, and V from this diagram. So what we're trying to find in this video is to know the smallest value of D so that this image can be captured on a screen, right? Because D is the distance between O and I. What should be the smallest distance of separation? That is what we want to see. Now, you would quickly see that from this, mathematically, that D is equal to U plus V. Then if I make U the subject, I would have that U would give me D minus V, right? Yes. Now, but then for me to apply this to my lens equation, I would know that the object distance from our sign convention so far in these lectures, we know that our object distance should always be what? Negative. So I would apply my negative for the object distance. Now going to my lens relation, I have 1 by F is what? 1 by V minus 1 by U. So that 1 by F becomes 1 by V. Now I will quickly notice that if I bring this object distance, which is carrying a negative sign, into this equation, it will change this one to become positive 1 by U, and my U becomes D minus V. So I have 1 by F equals, this is V, that is the LCM of this is V into D minus V. So that V would fizzle V, then I have this times 1, which would give me D minus V, plus this would fizzle this, so that I have V times 1, which would give me V. And you would clearly see that V minus V would fizzle plus V. And I'll be left with 1 by F equals what now? D all divided by, can I expand this? Yes. This times this is going to give me dV. This times this is going to give me minus V squared, right? So that I'm going to cross multiply in this case. If I cross multiply, I will then have that this would multiply this, or let's go this way first. This would multiply this to give us what? FD equals, this would multiply this to give us what? dV minus V squared, right? Now if I rearrange this, bringing everything to the left hand side and leaving the right hand side to be 0, I would have V squared minus dV plus FD equals what? 0. Now you will notice quickly that this is now a quadratic equation in terms of v. So this is v squared and this is minus dv. So this is a quadratic equation in terms of v. Now what are we looking for? We're trying to get the minimum distance between an object and its image so that a real image can be captured on the screen. So for you, when you're solving a quadratic equation, you want to get real solution. It means that a quadratic equation would have a real solution if the discriminant b squared minus 4ac is greater than or equal to what? 0. So whenever the discriminant b squared minus 4ac is known as discriminant of a quadratic equation. So if this condition is true, then your image should always be real. And remember, we're considering a real image. So we have in this case that our a from this quadratic equation is the coefficient of v squared, which is 1. Our b is the coefficient of v here, which is what? Minus d. And then our c is the constant, which is fd. So if I substitute this into this discriminant equation, I would have minus d all squared minus 4 into a, which is 1. And then c is fd. This should be greater than or equal to what? 0. So that I have d squared minus 4fd greater than or equal to what? 0. Now, if you factor this out, this is an inequality, but I don't want to solve for the other solutions. So I wouldn't need when it is less. So I'm just interested in greater than. So that is why I won't go through the method of solving inequalities, because the other solution, which eventually will be less, is not important to us. So we just need this solution greater than what? 0, so that you would understand why I'll be cancelling. So now you can see that d is common, right? So I can factorize the d and set that part to 0. I won't be needing it. So I'll just be left with d minus 4f greater than or equal to what? 0. I hope this is clear why I'm now having d, not d squared. Because there's a d here. There's a d. When you factor it and then divide through, you'll be left with just this. So it means, in this case, that d would be greater than or equal to what now? 4f, right? Yes. So this simply means that if you want a real image to be formed on a screen, then your distance between the object and the image should be greater than or equal to 4 times the focal length. So in a simple term, we can say that the minimum distance, the smallest distance between an object and its real image, so that the image can be seen on the screen, should be d equals 4f. This is the smallest. D equals what? 4f. So for you to always get an image on the screen, then your d should be greater than what? 4f. If you go below 4 times the focal length, will you find an image on the screen? No, you won't find a real image on the what? Screen. So the least distance that you should give between an object and its image or on this and the screen should be 4 times the focal length. Now let me ask you this simple question. If my focal length is 12 centimeter, right? Now what do you think should be the least distance below which I would not have a real image on the screen? Drop the answer in the comment section if the concept is clear to you. Thanks for watching this video. If you are yet to subscribe, please show me your support by hitting the subscribe button, comment on this video, like, and share with 10 of your friends. Tell them this is Prime Concept. Thank you.